In this PowerPoint, we are going to cover Chapter 3 of our textbook. In Chapter 3, we look at using queries to make decisions, which means performing calculations and summarizing data using queries. So when you're manipulating data in an Access database, you're going to want to perform calculations. An example of a calculation, a very simple one, is a field storing the number of hours worked times a field storing the hourly pay rate. And this is going to calculate the gross pay, okay? But calculations aren't always that simple. We might come across more complex calculations. For example, if you've received a paycheck, you realize that your gross pay is not the same amount as your paycheck, right? Your net pay is going to be lower due to some deductions like, EI or CPP or taxes or insurance or union dues, depending on where you work for. So some deductions might be a flat rate and others might be calculated based on the amount of the paycheck. So what appears to be a simpler calculation becomes quite complex. So in Access, we have built-in calculations and functions. Calculations appear commonly in queries, but it can also be added to tables, forms, and reports. So rather than performing a calculation outside of the database and then inputting the results into your database, you should really store the components of the calculation in the database, calculating values rather than inputting the values. So instead of using an Excel sheet to draw the data from your Access, performing the calculation in Excel, and then re-inputting that calculation, like the calculated values, back into your database, you should really perform the calculations right then and there in Access. And the reason is because doing so will reduce errors and inconsistencies. Okay, so for example, if your database stored the hours worked and the paycheck amount, both the fields would have to be updated if there was a change in hours the employee worked. However, if you only store the hours worked and calculate the paycheck amount, you don't have to worry about updating multiple fields. So the next time the paycheck is calculated, the results will be updated and corrected right away. Another example is that a table might contain the times that employees clock in and out of work. You can create the calculation in a query to determine how many hours each employee worked by subtracting the clock in field from the clock out field. Next, let's take a look at what an expression is. So an expression is a combination of elements that produce a value. And a calculated field is another term that you need to learn. A calculated field is a field that displays a result of an expression, so rather than the data stored in the field. So elements in a calculated field, you may find the following elements when you come across a calculated field. You might have an arithmetic operator, so like times, divide, plus or minus. You would have a constant, which is a value that doesn't change, okay? Such as, maybe the amount of tax, okay, so 0.15, or a number, okay, it could be negative or positive. Next, we have a function, so it could be a built-in calculation like PMT. It could be an identifier, so the names of fields, controls, or properties. Okay, so first let's look at the order of operations. The order of operations determines the sequence by which the operations are calculated in the mathematical expression. So remember that you look at things in the parentheses first. So that parentheses is the brackets. Okay, then the exponents, and then the multiplication, division, and then lastly the addition and subtraction. Okay, I think in Excel we also talked about the order of operations. Next, we're going to look at building expressions. So expressions can contain a number of different elements. Expressions can be typed manually or it could be inserted using Access tools. So next, I'd like you to please watch the video tutorial on creating a calculated field within a query. And when you're done with that video tutorial, please come back to the PowerPoint. Next, let's look at formatting calculated results. So when you're using calculated fields in queries, you might want to format the results. So spending a few moments formatting your output will make your query results even more readable. For example, if you're calculating a net pay, you likely don't care about anything after the 2 decimal places, right? So it makes more sense to say that you're making $980.15 a week rather than to say that you're making $980 and 1.49833432, and so on cents, because that's sort of irrelevant and it just looks messy. So a nice clean number like this would make more sense. So you want to go in and enter 2 decimal places. Next, let's talk about the property sheet. So to format a field in a query, use the property sheet. The property sheet enables you to change the way that a field appears. So for example, a numeric field has settings like number format and number of decimal places. Other data types will have settings specific to that data type. So think of the property sheet as the field properties in a table. Okay, it's very similar. So next I would like you to watch the video tutorial so you can look at formatting a field. And when you're done, please come back to the PowerPoint. Next, let's look at recovering from common errors. When you're creating calculated fields, there are a number of common errors that can occur. So one example is forgetting the colon between the column title and the formula. Okay, like so. So over here after surcharge, you're supposed to have that colon there. Okay. Spelling a field name incorrectly. You can see that I have a spelling error right here. Spelling field name incorrectly. So balance is also misspelled here. Okay, so if you spell things wrong, that's also an error. And also forgetting the order of operations. So if you don't check your formulas, you might get bad values. So let's verify calculated results. After your query runs, look at the field values in the datasheet view and look at the calculated values. You may find that, just by common sense, that the results don't make sense. In a real world scenario, you won't be given step-by-step directions like you are in the textbook, right? When we do our hands-on exercises. Instead, you're going to have to apply critical thinking skills to your work. So Access is going to calculate exactly what you tell it to calculate, even if you make logical errors in the calculation. I think we talked about this before when we're studying Excel, that the logical errors are really the most difficult ones to pick out. So I want you to stop and think about it when you're, doing your exercises, when you're running queries in Access. When you run a query, you need to analyze the results and ask yourself if the results make sense. So spend some time, think about it. The example here is assume that you're calculating a car payment for $10,000 car with monthly payments for 5 years. If your formula is incorrect, you may end up with a monthly payment result like $1,000. So if you look at your results, you should say to yourself, does it make sense for me to pay $1,000 every month for 5 years to finance a $10,000 car? Does that number make sense to me? And you can always check. You can verify results with a calculator or by copying and pasting data into Excel. You can recreate the calculations in Excel and compare the answers to the query results in Access. So the Access calculated field, the calculator, and the Excel calculations should all return the same results. The expression builder and functions. When you encounter more complex expressions, the expression builder tool can really help you create more complicated expressions. So the expression builder size lets you see complex formulas and functions as a whole. It also provides easy access to objects, operators, and functions. Okay, so creating expressions using the expression builder. The expression builder helps you create expressions by giving you access to fields, operators, fields, operators, and functions. When you use the expression builder to help create expressions, you can eliminate spelling errors in the field names. Okay? And when you insert a function, placeholders tell you which values belong where. So you can, prevent yourself from misspelling functions or field names, things like that. And you also get placeholders, so you put the values in the right place. So experienced users may already have these functions memorized, but for new users like us in this class, Expression Builder is really here to provide support for us and kind of give us the right directions, okay, and kind of prevent us from making errors, some errors. So here I'd like you to watch the video tutorial, please, on creating an expression with the expression builder. Using built-in functions. So a function is a predefined computation that performs a complex calculation. There are about 150 functions built into Access. If you're familiar with Excel, which we all are by now, many of these functions in Access will also be familiar to you. So we understand what inputs and arguments are, right, from Excel. Functions produce results based on inputs. So each input, like field name or number, it's used to produce output for a function known as an argument. So some functions have optional arguments which are not required but are necessary for your task. Okay, so you can leave the optional ones out. Let's look at creating an expression using the expression builder. So first, identify what functionality is needed. Then the next step is to check the built-in functions in the expression builder to see if that function that you need exists, or use search engines or use Access help. So if that function does exist, add the function to the expression box and replace the placeholder text with the argument values. So I'd like you to please watch the tutorial video on how to do this, creating an expression containing a function with the expression builder. And when you come back, please move on to the next slide. And the next tutorial video is going to be on calculating a loan payment with a PMT function. So sort of like a real-life example on how you would use the expression builder. And when you're done with this video, please come back to the PowerPoint. Moving on, let's look at aggregate functions. An aggregate function performs a calculation on an entire column of data, and it returns a single value. So an example of this is sum. So Access refers to the aggregate functions as totals. It's another word for the same thing. Totals can be added to the datasheet view of a query, or they can be added to a query's design view. Based on the data type, different aggregate functions will be available. So numeric fields are eligible for all of the functions, where short text fields are not, right? So let's take a look at an example to see why it's useful. So in the property database, the average, let's say the average home price per county could be presented in a query or in a report. So this gives a good idea to the buyers about home prices, let's say in a county. So if you're a home buyer and you're considering buying a property in Story County, Iowa, for example, for $150,000, and then when you look at the average price of a property in that county is $450,000, then you know that you're getting a good deal. Either that or that property is not a very good property. Okay, so let's look at how to add aggregate functions then to the data sheets. You can use total row, or you can use totals query. So total row displays the results of the aggregate functions as the last row in the data sheet view of a table or query. Okay, so totals queries, and the other method, it's created in the query design view. Let's look at total row method first in more detail. The total row method is quick and it's easy and has the advantage of showing the totals while still showing all the individual records. But the total row is, this method is limited when you need more in-depth statistics. So instead of the average sale price for houses, if you want to see the average sale price by the city, it's not possible with the total row method. And another thing that it's not possible or difficult to do is to see the average sale price, minimum sale price, and maximum sale price. This is also difficult to do with the total row method. So let's watch the video tutorial on using the total row method. And when you're done, please come back to the PowerPoint. Next, let's look at the second method, which is the totals query. Okay. The totals query versus the total row. Let's talk about the advantages over the totals query. The totals query contains an additional row in the query design grid, and it's used to display aggregate data when the query is run. So the two advantages it has over the total row, the previous method we looked at, is that you can show only the results of the aggregate function, so you can not show the details. And you can see the statistics by category as well. Okay, so the first advantage I talked about was that totals query doesn't show the details. If you want to see like a number of listings, average value, average size, you can use the totals query to get that data and not see the details. So instead of having like hundreds of rows of data with a summary row way at the bottom, which could be very easily missed if you scroll and scroll, the totals query displays only the aggregate functions results, which can be very useful and to the point. So please watch the video tutorial on using total query method, and when you're done, please come back to the PowerPoint. Next, let's talk about adding grouping to a totals query. So grouping a query allows you to summarize your data by the values of a field. For example, instead of seeing all overall averages, you might want to see the results for each county. So you might want to see the averages for each county. So you can add county as a grouping level to see the stats by the county. So let's watch the video tutorial to see how to add grouping to a totals query. Next, let's add conditions to a totals query. Okay, so totals query can provide even better information if you add a criteria. For example, you might want to see the number of houses, average prices, and average square feet for only the sold properties grouped by the county. So in the last video, we grouped by the county. Now we want to see only the sold ones. So we're adding a criteria. So let's watch the video tutorial on how to add conditions to a totals query. Next, let's look at adding a calculated field to a totals query. Calculated fields can have aggregate functions applied to them. For example, you might want to calculate mortgage payments, see the average of your calculation, and so on. Okay, so let's watch the video tutorial on adding calculated field to totals query. And that would be our last video tutorial for Chapter 3.